box contains 20 marbles, of which 2 are red, 3 are yellow, and 15 are black. 2 marbles are selected at random without replacement from the box. What is the probability that exactly one of the marbles is black? So, 2 marbles are picked out from the box. After the first marble is picked out, it's put to one side, it's not put back in the box, okay? So that's what that means there. It's kept away from the box, and then a second marble is chosen. We want exactly one of these to be black, okay? So if you think about it, we only want one black, okay? And one black has to appear out of those 2. That means the other marble can't be black, okay? So it could be red or it could be yellow. But we need to think about the different possible ways of doing this, okay? So if we write down probability of exactly one black, okay, and I'm going to use the letter B for black in a minute, but to sort of be clear in terms of what we want to find, we need to think about the possible ways of doing this. So we could consider the probability of the first marble being black, but the second one not being black. Now, first one being black, that's easy. The second one not being black, then that complicates things because it could be red or it could be yellow. So we could actually work out all of these different probabilities. We could work out probability of it being black and then red, or the probability of it being black then yellow. The issue is there's a lot of sort of work to be done there. So what we can do is we can look at it this way. We can say the probability of the first marble being black, okay, but the second marble not black, okay. So we put a line above it there to represent the opposite of black, so not black, and then that will contain all the other possibilities. That will actually wrap up all of the yellow and red, okay. So we could even do this up here, and I like to do this. I like to say how many black they've got there. So you've got 15 black marbles, not black, then it will be 5, of course. It will combine the red and the yellow, okay? So exactly one black. It can either be the first one black, the second one not black, or, of course, we've got another option. The first one might not be black, okay? That could be red or yellow, but the second one will be black, okay? So then it's a case of just working out these probabilities. So the probability of the first one being black, well, we've got 15 chances out of, remember there's 20 in total. And then the second one not being black, well, there's 5 of them that are not black, the reds and yellows here, 5. But the chances of the second pick being not black, well, you have 5 possibilities, but there's only 19 left in there now, remember, okay? Because you've already taken one out. So we have that there, yeah? So we can work out that probability. Or, so we can either have that route, or another route could be this route here. So when we have another possible route, we're increasing our chances. So we need to add, okay? So we're going to increase that probability. So then the probability of it not being black to start with, well, we've got 5 chances with the red and yellow out of course, 20, okay? So nothing's been taken out. You've got 5 chances of getting not black, red or yellow, out of the total of 20. And then the second one, so we're going to times, because we want it not black, and then the second one being black. Well, for the second choice, we've got 15 black still in there, but remember now 1 has been taken out, so it'll be out of 19. So essentially it's the same as this, isn't it? It's just reverse the multiplication here in terms of how we've done that. So times the tops there, that becomes 75. Times the bottom, well, 2 times 19 is 38, and 0, 380, and then same here, exactly the same. So then we add those fractions and we get 150 out of 380. We do not need to simplify because it doesn't ask us to.